I forgot one thing from the last chapter, one slide. I don't know how I forgot it, so it gets added to the start of this one. Doesn't really matter, hopefully, to you. And that's more about the truth and proof issue in statistics. We have two ways that statistics in an inferential sense gets used. One is called induction and one is called deduction. An example of induction would be taking a sample of people, taking 10 people, 20 people, 30 people, and saying, hey, we make you take extra vitamin C, do you get fewer colds? Then the question is, 20 people took vitamin C, got fewer colds. Can we extrapolate that to 6 billion people? Can we take something we learned about a small group of people and use it to cover a large group of people, to say something about a large group of people? That's called induction. If, on the other hand, we know that 1 in a million people gets a rare cancer, and then we go into southern Utah and we find that 10 people on one block have it, can we, from the fact that only one person in a million gets this, so there should be maybe 300 cases in the entire United States, what does it mean if 10 of them are on one block? This is a big deal, actually, and if we think about Nevada, we know that historically in Nevada, we used to set off nuclear bombs in the atmosphere here, and they would rain fallout down on southern Utah. And there's been lawsuits over whether or not the government was responsible for all the strange and weird cancers that have happened in southern Utah. So statistics gets used in this. Statisticians went and testified in those court cases, and in general, the people who got those cancers didn't win any money, but this is a basic statistical argument. So we have two fundamental arguments. You hear, hey, we did this study, you should floss. Flossing's good. Turns out those flossing studies weren't very good in how they were done. Very few people, a couple people flossed a couple times, and the dentist said, look, they're better. The reality is when they did large numbers and they looked at enough people to really count, they kind of concluded that flossing your teeth doesn't help you. So it's a very difficult task going from that sample, those few people, to the large group and trying to extrapolate out to a large group. We'll be spending a lot of time on these two things over the course of the semester, induction and deduction. So chapter 2 is really short. I'm just cutting a lot of stuff out this time. We want to talk about graphing things. When you graph data, the first thing you have to figure out is whether those data are time series or cross-sectional. We're going to graph them differently. If they're time series and cross-sectional, we graph them differently. Or the best way to graph them is often different. The easiest graph, the most fundamental graph we have, is called a scatter plot, and you can do both time series and cross-sectional in a scatter plot. Though more often than not, scatter plots are time series, and we'll see what that means. What are time series? We have these things called pie charts, which I'm sure you've seen before, and you'll see again. Pie charts only work for cross-sectional data. That's all they're good for. And then we have these things called bar or column charts, and they are useful in both time series and cross-sectional. So here's an example of a pie chart. This is the tax revenue of the state of Nevada. Pie charts are used when we have a whole, in this case, whole, that's W-H-O-L-E, a whole. In this case, the total revenue of the state of Nevada, how much money does the state take in? And then we can use the pie chart to divide that up. So we can see that there's one really big piece of pie here and there, and that's the taxes on the gaming industry. Then we have, up at the top, we have a kind of pinkish, which is the property tax, and that's the second biggest. Then down toward the bottom, we have the sales tax. That's the third biggest. And then we have other, and we have fees. Now, you may notice that this is an awful-looking graph, and that's because Excel does a terrible job drawing graphs. And if you were really going to do this in the real world, you would want to change these colors. And to do that, you click on them. It's really easy in Excel. You just double-click on them, To get it started, right-click, up will come a menu. You choose off the menu, pick a color, and change the color. Excel, for some reason, has all these pastel-ish kind of colors, and when you print them out on a black and white printer, they really look bad. So we don't like, if you ever do an Excel chart, you can't just leave it the way Excel draws it. You have to change it. They're all really bad when Excel just draws them. But hopefully from this, you got the idea of what a pie chart is used for, which is splitting up a total. So if we take all the people who are going to vote in the election, we split them up. You'll have a pie for the Republicans, a top pie for the Democrats, a pie for the Libertarians, a pie for the Green Party, and we'll have all these pieces that will add up to the whole pie. Column or bar chart looks this way. We can draw the same graph. So this is sales, gaming, property, fees, and other taxes. This is exactly the same graph, but it's not nearly as good. The pie chart is a much better way to represent what's going on in this with these data. We can see that gaming's big and all that here, but your eye catches that pie chart better. And again, you can see the colors aren't very good, and we'd probably want each one of these to be a different color. And again, Excel, not my favorite way to draw a graph, but we do what we can do. So, column or bar chart. This is a line chart, which can also be a scatter diagram if we don't draw the line. A scatter diagram is just a graph which has dots on it. In this case, we have the population of Las Vegas from 1970 to 2010, and this is from the census, so there hasn't been a 2020 census yet, so the furthest we got in the census is 2010. And you can see that this line chart just kind of shows a nice trend over time, and we can see what's going on. So the line chart, scatter diagram, again, scatter diagram would be dots for each year without the line connecting them. That scatter diagram is the best way to do time series. You could do this as a bar chart, and then you'd see a set of bars that were getting bigger over time. You could do that. It's not graphically as good. Excel kind of assumes that you want to do a bar chart all the time. It offers you that first because that bar chart is kind of universal and it can really do anything.